Good afternoon, students. Hello, how are you? Welcome to another amazing session from Infinity Learn, India's largest एग्जाम प्रिपरेशन प्लेटफॉर्म इन्फिनिटी लर्न. आपका स्वागत करता हूं. मैं हूं सुरेश अवारी, फैकल्टी ऑफ केमिस्ट्री. हाउ आर यू ऑल? गुड आफ्टरनून. हाय हाय हाय. I can see a couple of students. Uma, hi. Hi, Uma. How are you? Please confirm, can you able to see me and can you able to hear me? Yes, that's great. Perfect. Yes. So, welcome to the journey of NEET Step Up 2025 program. Are you all with me ready? So, we started these classes a couple of weeks ago. And we are running these classes with a lot of enthusiasm, with a lot of energy. Hi Pranav Balaji, hi, good afternoon. Great Ravindra Reddy waiting for you. And in the journey of the chemistry lectures, we completed grade 11 and the grade 12 topics. First 3 days of a week, a grade 11 topic. Next 3 days of a week, a grade 12 topic. In this journey, in this week, we started hydrocarbons. Yesterday, we completed preparation of alkanes and we are going to discuss about isomerism of alkanes that we skipped in isomerism topic in the previous week. If you remember, if you don't remember, please review the videos that are available. And we will be finishing the chemical reactions of alkanes as well in this today's class. That is the plan, right? So, as it is a routine, these lectures are perfectly useful for those preparing for NEET 2025 and those who dropped grade 12 and preparing for a drop and NEET 2025 and those who completed 11th standard and stepped into 12th standard, ये sessions आपका फायदा होगा. And these sessions are absolutely free on YouTube platform given by Infinity Learn by Sri Chaitanya, and we request you guys please like these sessions and share and subscribe, and telegram channel भी दिया जाएगा आपका description box में, so you can just click it so that you will be getting continuous updates on that. हाँ, yes, of course. Ishita, hi. Parveen, hello. Arhan, good. Ravinder, क्या बोलना चाहता हूँ? Due to some technical problem you missed class today, there no problem. Thank you. So yesterday you are there, but sometimes you are invisible. I remember. है ना बेटा? Uma, who is that? Can you all confirm? Can you all can hear me? Can see me? Any lag or any buffering from my side? Please confirm here. Yeah. चलो. Please confirm. एक fire emoji डालो और एक thumbs up डालो. Can you able to see me, hear me? Some buffering is coming. Saranya, hello. Audible, that's good. Ishita, that's good. Perfect. So, yes, I am starting Arhan. So, today's class of interest is conformational isomerism. If you recall the isomerism, we have here conformations. Before going for the conformations, why conformation isomerism arises, we need to know. I think you can see this font style and all, right, because the operator who made changed the color, that's why. Okay, anyways, let's see conformations. Isomerism, just a small recap. I don't want to tell the entire story and waste my time and your time. Hi Fazal Khan. Hi Raj Lakshmi. सरन्या, हिंदी और इंग्लिश दोनों भी है, कौन सा चाहिए आपको? What do you like, English or Hindi or English? Right. So isomerism. This isomerism, oh, Saranya, fine, we can go with that, don't worry. So those students from the North Indian background they might like combination of Hindi and English, you don't have to worry about that. So A class sabko fayda hona chahiye. This class is supposed to be beneficial for every student, right? Okay. Isomerism is a phenomena where a molecular formula, two compounds have the same molecular formula, but they differ in certain properties. So this isomerism is of two types. Short recapture: structural and stereo. Under the heading of structural, we have chain isomerism, position isomerism, you have functional isomerism, metamerism and tautomerism. Everything we discussed. If anybody miss what is structural isomerism and the details about that, you just go through the previous YouTube videos that is given by me. Okay, that's why I always ask you to just like the lectures and share it, so that it is going to be useful for the student community. My dear students, talking about the stereo, you have conformational isomerism and configurational isomerism. Okay, I don't want to give that different type. Okay, optical isomerism in our understandable language. Compounds having same structure, okay, same molecular formula, same structure, differ in the optical properties, okay, and the geometrical isomerism, they differ in the geometry and the conformations. The way we understand here, okay, DL notation, optical activity, dextro and levo comes over here, right? Fine, beta. Now, talking about this geometrical isomerism, carbon double bond a carbon, and a carbon single bond a carbon. Let us say a ball, this is a ball, these two balls are connected by using one stick. है ना? Assume that one stick, this is a ball, this is a ball, and this is a ball connected by using one stick. Now my question is here, can you able to rotate the ball with respect to the stick? Yes, we can rotate now. You can see I am rotating. Are you getting or not? So rotation about the atoms by single bond is possible. Now let us say two sticks are there. When the two sticks are there, you can't rotate it, na? You can't rotate it. So that if this is a ball connected by two sticks, you want to rotate it? You want to rotate it like this? Yes, rotation is not possible. So rotation is restricted. It is not possible. It is possible. So as this rotation is not possible, the groups present here, their positions in the space is restricted. A, B, X, Y. A and X on the same side, B and Y are on the same side. Okay, you can have the opposite side. So they differ in, hi Dhanraj, they differ in the geometry with respect to the plane of the double bond. They arise as geometrical isomers. Understand? Clear better? That's great. Now, cis and trans comes under geometrical isomers, Ravindra Reddy. Now, talking about if you take the carbon tetravalency A, B, C, X, Y, Z, as their positions are able to rotate, this atom has A, B, C, this is the atom has A, B, C, right? This atom has X, Y, Z. This atom has X, Y, Z. Now, this atom A and B are connected by a single bond, are able to see my camera, and when you see the structure like this, you can see like this and you can see like this, they can change their positions. ABC can change, XYZ can change, because the bond is rotated. You have to feel the bond rotation, then only you can understand conformational isomerism. Okay, yes Dhanraj, और कुछ बोलना चाहते हो तो क्लास होने दे यार पहले. Okay, let us first finish so that, so A, B, C relative positions are changed with respect to X, Y, Z as this bond is able to rotate. So, if it is understood, you can undergo conformational isomerism. Got it beta? This is just introduction here. Just introduction. That's great, Ishita. So, let us see conformational isomerism or conformations. So, electron distribution of sigma bond, that is what you say carbon and carbon, there is a sigma bond you want to say. Electron distribution of sigma bond or molecular orbital is symmetrical. It has cylindrical symmetry if you remember chemical bonding. Yes. Aspirant Ishita और क्या बोलना चाहता, just retract it. Okay, Saranya. So, and symmetrical around the intermolecular axis. This is a nuclear, you can say internuclear axis or molecular axis. This is the molecular axis or sigma bond. Sigma bond permits a free rotation. So, this is the key point in conformational isomerism. Yes, Sharanya. So, conformations arises. So, when this carbon and this carbon is rotated, its bond. So, along this positions A, B, C groups and X, Y, Z groups, they differ in their relative positions and produces how many? You got like this, you got like this, you got like this, you got like this. Total infinite number of positions that can be obtained by free rotation about a single bond. Whenever single bond is there, conformations are possible. So, they are called conformers or conformational isomers, right. So, these conformers differ in energy and stability. You know the relation between energy and stability, my dear students. Tell me, you know the relation between energy and stability? So, energy and stability inversely proportional to energy. ओके जिस मॉलिक्यूल का एनर्जी ज़्यादा है उसका स्टेबिलिटी कम होगा एंड वाइस वर्सा. द मॉलिक्यूल विथ हाई एनर्जी विल हैव द लोएस्ट स्टेबिलिटी, राइट Saranya? फाइन. सो फ्री रोटेशन रिलीव्स द स्टैटिक स्ट्रेन ऑफ द मॉलिक्यूल. ये स्टैटिक स्ट्रेन क्या है सर? देयर इज अ टर्म कॉल्ड स्ट्रेन. द टर्म स्ट्रेन makes a sense in the conformational isomerism. So, lower the energy molecule will have more stability, or Ravinder, perfect. So, a strain, what is, I want to make you to feel strain. Okay. So, let us take these two fingers, they are close, I do not have any pain, they are separate, I do not have a pain. They are maintaining a specific angle or permitted angle so that I do not have any pain. But if I increase the pain, it is gaining some pain here. So, that pain due to this angle between these two fingers is called angle strain. Understand? So, I mean to say, if this is an atom here, this is an atom here, bond, this is a bond, and this is a bond atom here. If there is an angle, that is called bond angle. If that bond angle is more than expected or less than expected, there will be a strain, that is called angle strain. Understand? Yes. So we'll talk about this strain. Strain is of various types. Steric strain, angular strain, van der Waals strain comes under this. So you need to understand before we go into the conformational isomerism. The type of repulsive interaction is called torsion strain. Ravinder, Raghavar, great. This type of repulsive interaction is called torsion strain. Of course, torsion means twist. Clear? Torsion means twist. Great. So let's move ahead. So different terms used in this conformational isomerism. Any doubt? Chalo. So what is the bond angle? Bond angle. The angle between any two bonded atoms attached to the same central atom. So I mean to say, let's say atom A is bonded to atom B and atom B. That is the average angle made between two bonded atoms with respect to central atom is called bond angle. If this bond angle is less or more than expected, it will have some kind of pain or strain. Talking about dihedral angle. The dihedral angle means if you assume a molecule is a plane and another part of the molecule is another plane. ओके जैसे आपका हाइड्रोजन पेरोक्साइड में है, हाइड्रोजन पेरोक्साइड कैसे देखते हैं? यू जस्ट ओपन hydrogen peroxide, oxygen and hydrogen is on one plane, hydrogen is on one plane. So if you see the angle between two planes, that angle is known as dihedral angle. Okay, that is called, you can see angle between any two bonds of adjacent atoms of the same plane. So I just want to say dihedral angle. You can see this is a carbon better, this is carbon, है ना, this is carbon, okay, this is methyl group and this is hydrogen. So if you consider this, the angle between these two bonds is called bond angle. Now this is in one plane, the same molecule I just want to show here, this is on one plane, so this is in one plane. Right, and this is on another plane, this is on another plane. So this plane and this plane has different angles. So that angle between this plane and this plane is called dihedral angle. Hope you understand. Hope you understand. If methyl group here and this methyl group here is like this, right? Now if you consider the angle is 0, got it? If methyl group and methyl group are like this or like this, if you take the angle, you can see 45 degrees or 60 degrees, 90 degrees, 180 degrees, are you getting or not? That is called dihedral angle. So you have to just don't go with bugging the books and all, you just see, visualize chemistry. If you visualize आप molecule का देखने का कैसे सीखो, then only you will understand beta. Great beta. Open book structure, Pranav Balaji, thank you. What that is for hydrogen peroxide. I didn't read your message, sorry. Okay, hope you all understand. So I come across with the bond angle, I come across with the dihedral angle, and I come across due to the free rotation, क्या क्या चल रहे हैं? Who is rotating here? Who is rotating here? He is rotating. The bond is rotating. Okay, like this. So that entire carbon is going to be rotated, entire carbon is going to be rotated like this. मिथाइल ग्रुप, हाइड्रोजन एंड ब्रोमीन है ना. हियर इज मिथाइल ग्रुप ना, ये कार्बन का, ब्रोमीन है ना, and this is hydrogen na. So that can be rotated like this. Got it? Yes. Risha, you are late. Why? Late. Okay. So bond length remains constant. You can't change this bond length due to rotation. Bond angle remains constant. Bond angle is not changing, it's same only, but dihedral angle changes. In excellent notes, you all get these notes, in Telegram channel in a PDF format. Okay, I request my dear students, please join in the class with book and interact with me by chat box, and you just talk to me and you can write along with the class as it's going on. Any doubts? हाँ, क्यों लेट है भाई? रिशा, why you are late? Can you all able to hear me and see me? Just confirm it once, because some kind of buffering is seen. Can you all see me? Thank you, Ravinder. Thank you. Yes, let's go. So, kind of glimpse, kind of feel, kind of compliments, kind of appreciation makes as a teacher more energetic and more deliverable. Okay, it is absolutely non-profit service we are giving on YouTube platform. My dear students, for NEET Step Up program, we all doing a great thing together. That's why we always say, please share these sessions with your friends and ekbar like maro. So keep on charting so that our YouTube videos are going to be promoted. उसमें कुछ फायदा नहीं, आप पैसा कमाना का नहीं कर रहे हैं हम. Okay, it is for the good service. If you follow these lectures right from 12 o'clock afternoon to evening 6 o'clock, physics, chemistry and bio faculties are teaching so hard and so such a nice manner, इतना प्यार से, okay, at the level of NEET examination. If you follow these sessions without fail regularly according to the teacher guidelines, if you work seriously, definitely you will be a topper in NEET 2025. हमारे ऊपर यकीन रखना. So भरोसा करना. We are giving a promise that we will do it. We all together we can do it. है ना? You are all with me. So this is a secret. Due to a conformations में क्या, the rotation of bond is taking place. उस रोटेशन में क्या चीज चल रहे हैं? ड्यू टू रोटेशन व्हाट आर द थिंग्स आर हैपनिंग? बॉन्ड लेंथ इज नॉट चेंजिंग, बॉन्ड एंगल इज नॉट चेंजिंग, बट डायहेड्रल एंगल इज चेंजिंग. डायहेड्रल एंगल है क्या? डायहेड्रल एंगल मीन्स एंगल ऑफ दिस ग्रुप एंड दिस ग्रुप. ओके, एडजेसेंट एटम्स का जो ग्रुप है ना, दोनों के एंगल कितना है? assume this is in the plane. So based on, so once the schools are open, the timing is not changed beta. Okay, so timing will be same. Pranav Balaji, if you want to just watch these videos, you can see the recordings, and also you can just opt for so many courses that is given by Infinity Learn according to your time slot that can be selected. Okay, if you want me to come and teach in your batch, that you have an option to select Pranav Balaji, that also you can do it. You can talk to Infinity Learn customer service department, they will take care of you, right? So for that you need to install Infinity Learn app so that you get contact and the people get contact with you to take care of you. Let's आगे बढ़ेंगे. Come on. So different types of strains, I said types of strain, it can be angular strain or torsional strain and van der Waals strain. Three types of strains beta. Let's talk about angle strain. I just given you, this is called angle strain. Due to change in bond angle mainly observed in cyclic compounds. So that is called angle strain. So this angle strain due to, you can see better, this is okay, this is Bayer's strain theory बोल रहा है आपका. हर कार्बन एटम साइक्लोप्रोपेन, साइक्लोब्यूटेन, साइक्लोपेंटेन, साइक्लोहेक्सेन, कार्बन जब इसका टेट्रावैलेंट है sp3 हाइब्रिडाइजेशन में है, सो थीटा इज गोइंग टू बी 109 डिग्रीज 28 मिनट्स ना, 109 डिग्रीज 20 मिनट्स आना चाहिए. It should be 109 28 minutes, but if you check these values, it is 60. It is expected 109 degrees, it is just 60. So very less than, almost half than expected. So the bond is so painful. Okay, so let's see, this angle is 180 na. If we want to make it 90, what will happen? It टूट जाएगा ना, it will break. Similarly, it is expected 109, it is 60. Due to that pain, strain, this bond can be broken. That's the reason why cyclopropane behave like an alkene. It decolorizes bromine water, it decolorizes KMNO for Bayer's reagent. Remember? हाँ, रिचा शर्मा, yes, I do agree with you. ये सभी का प्रॉब्लम होता है. ये प्रॉब्लम आपका, you can just talk to, you install the app and just say your concern, the people will come and discuss with you. ठीक है, a separate team is there. रिचा शर्मा, right? Pranav Balaji, right? You all, you just give me a thumbs up. How many of you installed Infinity Land app in your mobiles? Just I want to know out of curiosity. Come on. ओके, जल्दी इंस्टॉल करना है यार. ओके, आगे बढ़ेंगे. सो एक्सपेक्टेड एंगल, सो एंगल स्ट्रेन is expected angle minus actual angle by 2. Okay, it is 90. Okay, it is 105. आसपास में is 120. Right. So as angle is value is increased, the bond is getting relaxed. You will discuss in the Bayer strain theory. Okay, NEET के इतना नहीं चाहिए. So torsional strain. So due to repulsion between bond pair electrons of adjacent atoms. So मैं क्या बोलना चाहता हूँ? So here carbon, let us see, this is a hydrogen and this is a hydrogen. These two hydrogen is making a repulsion. Because of this repulsion, some pain will come, that is called torsional strain. Got it? That's fine. So angle strain, so torsional strain. So torsional strain is directly proportional to distance between bond pairs. Okay, inversely proportional to distance between bond pairs. As the distance between these two atoms decreases, torsional strain ज़्यादा होगा. Okay, van der Waals strain. Van der Waals strain. Van der Waals strain means, you just say the same example I just want to take. यहाँ पर हाइड्रोजन के जगह में मेथाइल ग्रुप लगा दिया मैं. अभी जो रिपल्शन मेथाइल ग्रुप के बीच में, द रिपल्शन बिटवीन मेथाइल ग्रुप एंड मेथाइल ग्रुप इज मोर रिपल्शन देन द रिपल्शन बिटवीन हाइड्रोजन टू हाइड्रोजन. ओके, सब क्वाइट बैठ रहे हैं, एवरीबॉडी सिटिंग क्वाइट ओनली. सो हियर मोर रिपल्शन. Here less repulsion. So repulsion between atoms bonded to adjacent atom, that repulsion between this and this is called as van der Waals strain. You have angle strain, you have torsional strain, and this is van der Waals strain. Van der Waals strain increases as bulkiness of the group increases. Okay, van der Waals strain is also called as steric strain. In some books it is written as steric strain, and some books it is written as van der Waals strain. Ravindra Reddy, okay, you are Sri Chaitanya Bacha. Okay, very good. Great, great, great. So, the different types of strains we experience and we just use generously in conformational isomerism. Different types of strains. Total strain is equal to van der Waals strain and torsional strain. दोनों मिलके बोलने हैं, but looking at the molecule we can say. Okay, more is the strain, more is the energy. More is the energy, less is the stability. And van der Waals strain is also referred as steric strain that I already mentioned. So, let us see. Consider this particular molecule and this structure. This structure. Let us talk about first conformations of ethane. I just want to give a manual description, then I will go into the details of the presentations, right. So, conformations of ethane. How we write the structure of ethane? ethane का फॉर्मूला क्या हो? फटाफट बोलो चार्ट बॉक्स में. हाँ, श्री भगवान 8228. It is C2H6, right. Now, let us see, this structure contain 2 carbon atoms bonded. हर कार्बन एटम का 3 हाइड्रोजन मिला के, this is going to be the structure of ethane. If you understand conformations now, you can do many of the things in the NEET examination. CH3 and CH3. So, you just keep awake at the chart box. So, this can be drawn in 2 ways. One is Newman projection. Just let us talk about the Newman projection. ये Newman projection में ये हाइड्रोजन, ये कार्बन and A carbon, है ना, A carbon and A carbon. So, these 2 carbons are bonded like this, 2 balls. There are 2 balls, है ना, there are 2 balls. Each ball has 3 hydrogens. If I show like this, this is this carbon, this is this carbon, है ना. Now, these carbons are shown right in front of you, keeping in front of you, right. अभी तो कितना atoms देख रहे हैं? How many atoms you can see? They are linearly arranged, so that only first atom, front atom you can see. Rear atom, पीछे वाला जो कार्बन है ना, ये नहीं दिख रहा है. That's the reason why, मान लो ये पहले कार्बन है, इसका पीछे जो सेकेंड कार्बन एटम भी है. समझ में रहे क्या? Are you able to understand? Now, ये पहला जो कार्बन का है, हाइड्रोजन है, so they are shown like this, right. ये पिछले वाला जो कार्बन एटम के पास और 3 हाइड्रोजन है, ये डॉटेड लाइन बना के दे देता हूं. हाइड्रोजन, समझ में आ रही क्या? So, this is how it is shown. It is called as Newman projection. ठीक है? Understand or not? This can also be given by using Sahar's projection. Sahar's projection का मतलब है, ये दोनों कार्बन एटम है, they are shown like this बस. And this is a carbon. ये कार्बन का जो 3 हाइड्रोजन्स है ना, 3 हाइड्रोजन्स shown like this. इसका 3 हाइड्रोजन्स shown like this, right. So, this is what you call it as Sahar's projection. So न्यूमैन प्रोजेक्शन ज़्यादा इस्तेमाल करते हैं साहर्स प्रोजेक्शन से. You all understand? Richa, fine. लाइन विड्ज प्रोजेक्शन वो थोड़ा सा अलग होता है. लाइन विड्ज प्रोजेक्शन थोड़ा सा अलग होता है रविंदर. ओके, राइट. Sharanya, are you there? Hope you are understanding. Hope you are understanding. Great, great, great. Right. So talking about this is the first carbon. पीछे और एक कार्बन है. फर्स्ट कार्बन का जो ये हाइड्रोजन है, ये हाइड्रोजन है, ये हाइड्रोजन है. 3 hydrogens in the first carbon. Okay, 3 hydrogens in the second carbon. You can see first carbon hydrogen, second carbon hydrogens, they are on the same axis, right? I just want to keep front carbon intact. I just want to rotate back carbon. Just I want to say like this. Rotate किया, पहला ऐसा था. Look at this angle exactly. I just want to rotate it. Array, chemistry is a funny, and if you understand, it's a funny subject here. हाँ, न्यूमैन प्रोजेक्शन में से ज़्यादा इस्तेमाल करते हैं. Okay, Saranya, are you there? Yes, clear. That's good. I'm just taking care. Okay, right. So I just want to take just a small turn, just a small turn. 60 degrees angle rotate करना का कोशिश कर रहा हूँ. मान लो ये फ्रंट कार्बन इंटैक्ट रहना. ओके, पीछे वाला जो कार्बन है ना, ये 60 रोटेट करना कोशिश करता हूं. सो दैट व्हाट हैपन, कीपिंग द फ्रंट कार्बन इंटैक्ट, है ना. एंड इसका जो हाइड्रोजन है इंटैक्ट, पीछे वाला जो कार्बन है ना, ये वाला इससे 60 डिग्रीज रोटेट करने का कोशिश कर रहा हूं, है ना. 60 डिग्रीज रोटेशन का मतलब इट कम्स लाइक दिस. सो एंड दिस विल कम, जस्ट फील इट, इट कम्स लाइक दिस. It comes like this and it comes like this. So this is one type of conformer, this is another type of conformer. जिस conformation में डाइहेड्रल एंगल कम से कम है, डाइहेड्रल एंगल का मतलब क्या, एंगल बिटवीन दीज टू कम है. द एंगल बिटवीन दीज टू is 0, है ना. and this has angle between these two is 60. so this आपका लग रहा है इक्लिप्स का जैसे है. इक्लिप्स में क्या होता है, सन, ओके, मून, राइट. जैसे comes on the same angle ना, it comes like this, right, in the same angle. एंगल 0 होगा सोलर इक्लिप्स में. ओके, and that is called eclipsed conformer. And this is the conformer, the angle is maximum, so that this is what you call it as staggered conformer. Two major conformations are seen. Okay, and Saranya, tell me which conformer has more energy, you tell me. I am asking हाँ, Saranya, which conformer has more stable? Yes, eclipsed, staggered, two conformers are there. Okay, chalo. Come on, Saranya, come on. Staggered. Saranya, come on. Ishita, come on. So as these two atoms are close together, okay, in the space, they have more repulsion. More repulsion means more energy and less stability. So I just want to say here, अरे कौन बोल रहे नीट एग्जाम टफ है, नीट एग्जाम बहुत आसानी काम है. इफ यू हैव कॉन्फिडेंस इन द सब्जेक्ट फॉर व्हाट यू आर स्टडिंग, राइट. नाउ एनर्जी, okay, maximum for staggered or eclipsed. And stability, maximum for staggered. And conformations of ethane, how many conformations are possible? How many conformations are possible for ethane? Saranya, yes. You given answer late, okay. Okay, talking about how many conformations are possible for ethane? You tell me. Waiting for your answer. How many? 3. Pranav, okay. No, 2, okay. Ishita, tell some number na. Tell some number. 7. Oh, Pranav Balaji, you type and retract, type and retract. Okay, 2, okay, no problem, no problem. Richa, you tell me how many are there? Infinity. We are students from infinity land who have infinite possibility of conformations. अरे थोड़ा किताब देना यार कम से कम. Ishita, fine. So I just want to say, for alkanes, infinite number of conformer possible. You can say from here to here, this to this extreme 60-degree rotation is possible. Sharanya, if you rotate 1 degree, 2 degree, 3 degree, 60 degree, 90 degree, 180 degree, 360 degree, each degree is subdivided into radians. So like that, if you take for 360 degrees, you have infinite number of possibilities are there. Understand? Yes. Now we'll go. So we know what is eclipsed and staggered, right? So talking about types of conformers, you take CH2 one atom, CH2 one atom and a CH2 another atom. You have staggered and conformations and eclipsed conformation. This carbon and this carbon, front carbon is just shown and back carbon is there. So let us talk about the carbon CH2 with X is the front carbon. It has H, and here it is X, and Z, this carbon atom has 2 hydrogens, so this is called eclipsed form. In this eclipsed form, the angle between these two is dihedral angle. It is theta is equal to dh, theta is equal to 0. It is on the same axis. Got it? Infinity. Okay, very good. Now let's talk about staggered. In this, let us keep the front carbon intact. X hydrogen and hydrogen, and it is maintaining 60 degrees here. If it is moved 60 degrees, or you can say anti, this is a staggered conformation. Now, anything between staggered and eclipsed is called skew conformer. Between anything between staggered and angle, staggered and eclipsed is called skew conformation. It's called Gaussian also. Okay, we'll discuss about this. This X could be a group, or Z could be another group. Oh, right, fine. Hope you are understanding. Come on. So this eclipsed is of again many types, fully eclipsed and partially eclipsed. दोनों सेम देखते हैं. Whenever bulky groups, जब bulky group साथ में आते हैं ना, that is called totally eclipsed, fully eclipsed. But partially eclipsed means if the bulky group is away but eclipsed with hydrogen. If bulky group is eclipsed with hydrogen, it is called partially eclipsed. If bulky group खुद eclipse कर रहे हैं, that is fully eclipsed. Okay, that you can see in N-butane conformers. Got it? Clear? So these are the technical terms, are very important to understand. X, Y are the bulky groups. मान लो ये हाइड्रोक्सी ग्रुप होगा, ये मिथाइल ग्रुप होगा, वो अमीनो ग्रुप होगा. ठीक है शरण्या, होप यू आर अंडरस्टैंडिंग. राइट, yes. So you have eclipsed, staggered and skew or Gaussian. Okay, so eclipsed you have two types. One is fully eclipsed, bulky group versus bulky group together, and partially eclipsed. ये eclipse का जैसे है लेकिन eclipse हाइड्रोजन का साथ है. Yes, it is. Okay, talking about staggered. The two bulky groups are separated by 180, that is anti, or if it is two bulky groups are separated by 60, that is called skew or Gaussian. We discussed in the previous slide. So staggered is of two types. So we talk about Gaussian ज़्यादा stable है, anti ज़्यादा stable है. Which is more stable between anti and Gaussian? You tell me. You tell me. स्टेबिलिटी का वजह से. यू टेल मी. हाँ, यस, क्लियर. टेल मी विच इज मोर स्टेबल. आई वांट टू से इन द चैट बॉक्स हु इज गिविंग द रेस्पॉन्स. रविंदर विल गिव. ओके, ईशिता, प्रणव, ओके, राधा कृष्णा. हाँ 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 हाँ, गौशी इज गोइंग. अरे एंटी मीन्स ये इस तरफ है, ये इस तरफ है. एक कश्मीर में है और केरला में एक है. सो दोनों के बीच में रिपल्शन कम होगा, स्टेबिलिटी ज़्यादा होगा, है ना. यहाँ पर एक दिल्ली में है और राजस्थान में है. सो नज़दीक लग रहे हैं थोड़ा बहुत. सो द रिलेटिवली रिपल्शन हो सकते हैं. ओके, ये कम स्टेबल होगा, है ना. ठीक है बेटा. सो मैं हमेशा क्या बात कर रहा हूँ, ये स्ट्रक्चर का देखना का कैसे, ये सीखो पहले. ऑर्गेनिक केमिस्ट्री का सीक्रेट वहाँ है. दैट्स गुड प्रणव. सो नाउ स्टेबिलिटी ऑफ कंफर्मेशन, टाइप्स ऑफ स्ट्रेन. जहाँ पर स्ट्रेन है वहाँ पर स्टेबिलिटी कम है, एनर्जी ज़्यादा होगा. दैट इज द थंब रूल. कीप इन योर माइंड एंड विथ लॉट ऑफ थम्स अप्स. कहाँ है थम्स अप? कहीं नहीं देख रहे हैं. राइट, थंब रूल क्या? Wherever any strain is there, there more energy, less stability. Okay, come on. So van der Waals anti-negligible because anti one group here, one group here. Okay, Gaussian you can consider, partial eclipsed you can consider, fully eclipsed you can consider. Torsional strain anti it will not be, and Gaussian and partially eclipsed and fully eclipsed में होगा. So total repulsions. So here free energy, potential energy is greater than Gaussian anti. I want to say here the stability. This you keep in your mind. Okay, I will show you what kind of special cases, how to take their orders by looking at the structure. If you memorize this, just memorize as a case of notes. But as we are going ahead, we just see any intermolecular forces are there. Conformations of ethane we discussed, front carbon and back carbon. When you see the Newman projection, two hydrogens, okay, are in 60. If it is 60 is rotated, you are going to get eclipsed. So that torsional sign repulsion, eclipsed is more than staggered, right? We discussed this. I just want to give you as a slide here, right? And van der Waals strain, हमेशा eclipsed is greater than staggered, and total repulsions again eclipsed is greater than staggered, and potential energy eclipsed is greater than staggered, stability staggered is greater than eclipsed. Why? Because stability, energy, both are inversely related. Hope you are understanding. Video is lagging. Okay, everybody please confirm, is my video is fine, streamlined, fine, confirm, confirm, children please confirm, please confirm. I am just waiting for the response. Okay, so other students is fine, so that there might be some issue with Sharanya. You take care of your system and internet connections. So you can see for energies, it is for ethane, this is eclipsed, 60 rotation, staggered, eclipsed staggered बन गया, staggered eclipsed बन गया, फिर भी staggered बन गया, फिर भी eclipsed बन गया, staggered बन गया. You can see the rotation appears like this. Potential energy diagram. It do not very zero na, and the energy difference between these two is given as 12.55 kilojoules. Don't have to memorize this value. You don't memorize this value. Fine? Fine. Now, conformations of N-butane. I will explain what is N-butane here. So, N-butane, normal butane, N-butane. Can I write this N-butane as CH3, C, H, H, C, H and H and CH3. This is N-butane. You have carbon number 1, 2, 3, 4, right? So I just want to make this carbon 2 and 3 as a pointer. Carbon 1 and 2. So let's see this carbon 1 and carbon 2, right? Carbon 1 is linked to carbon 2, carbon 3 is linked to carbon 4. So that these two hydrogens, one methyl group. And this methyl group, it is given like this. This is conformation of N-butane, Newman projection. Are you able to understand? So, let us see this conformation of N-butane. In this conformation of N-butane, you can see this is completely two methyl groups are on the same side, na? So, it is fully eclipsed. If you take the methyl group on the opposite side, like this, this is anti-conformation or fully staggered conformation. The technical terms are very important beta to understand this, right. So, let us go and see. So, this is a conformation of a butane, methyl group दिख रहा है क्या, and यहाँ पर और एक methyl group. These two methyl groups are completely opposite to together, right. So, that is what you call it as anti-conformation, that is anti-conformation. So, this methyl group and this methyl group are on the opposite side, right. So, it is anti 180 degrees. I just want to keep front carbon intact, so that I just want to move back carbon 60 degrees. So, methyl group यहाँ पहुँच गया. So, दोनों क्या कम आ रहा है ना. So, it appears to be eclipsed, but hydrogen के साथ eclipse हो रहा है. So, it is called partially eclipsed. Okay, इससे वो ज़्यादा स्टेबल, ज़्यादा एनर्जेटिक है. थोड़ा सा रिपल्शन इंट्रोड्यूस किया जाएगा है पर राइट. नाउ और एक 60 डिग्रीज करना है और दूर कम हो गया, नज़दीक बन गया. सो दैट और रिपल्सन बढ़ गया. So, that is Gaussian or squeeze conformation. And if they come and these two methyl group dihedral angle 0, तभी dihedral angle 0 है, ये fully eclipsed है, repulsion ज़्यादा से ज़्यादा होगा, stability कम से कम होगा. ओके, फिर और 60 डिग्री होने तो गौशी बन गया. ये दोनों बराबर है, देखो दोनों बराबर है. Are you getting or not? Clear? So, if you see कार्बन टू कार्बन बॉन्ड रोटेशन C2 C3 के बीच में है. ओके, C1 is a group and C4 is a group, and if nothing is memorized, select two middle carbon atoms. Okay, no problem. Here the stability, energy किसका ज्यादा होगा बेटा? पहले एंटी का, बाद में फुल्ली एक्लिप्स्ड का, बाद में पार्शियल एक्लिप्स का एंड गौशी का. You understand? You just keep this in your mind. So, whenever you write examination for NEET, it is there in the NCERT. It NEET and any kind of examination, you will have the question based on the stability and energy. Energy stability का दोनों का relation क्या? अभी स्टेबिलिटी है उल्टा, स्टेबिलिटी है उल्टा. सो दैट एंटी लेस देन fully eclipsed, partially eclipsed and Gaussian. Got it? So, like that, if you see the same, next. So, this is about, yes, N-butane. We have Gaussian, anti and partially eclipsed. The graph comes like this. Highest energy is fully eclipsed and lowest stability. Lowest energy is anti, it is going to be the highest stability. So, by looking at this, you can calculate the energy. So, energy difference between fully eclipsed and anti form is going to be 20.9 kilojoules. Please don't memorize these values. Okay, are you with me? Come on. right? So आगे बढ़ेंगे. Now when these polar groups are there, okay, whenever these polar groups are there, like OH, F, NO2, they can form hydrogen bond, तभी Gaussian form is more stable than anti-form, okay? Because if you consider this, there is ethylene glycol, there is a hydrogen bonding between these two, therefore Gaussian is more stable. This is Gaussian, am I right? Whereas if you consider if Z is going to be any group, always Gaussian form is more stable than antiform due to the ion dipole interactions, that what we discussed. Okay, let's talk about physical properties of alkanes. Any doubt so far? So we completed majority of the conformational isomerism, है ना Saranya? Fine. So alkanes, C12 methane, ethane, butane, C12, C4 are gases, okay, and C52, C17 are liquids, and C18 onwards they are called solids or semi-solids. That's why we have the petrochemicals, gas, petroleum gas and petroleum liquids. So boiling point is directly proportional to molecular weight. Methane less than, ethane less than, propane, like that. If molecular weight is same for same molecular formula, then boiling point is directly proportional to branching. As branching increases, surface area decreases, boiling point increases. So I just want to say boiling, so straight chain molecules have higher interaction than branched. That's the reason why I just want to say C5H12, example C5H12. In that you can see 1, 2, 3, 4, 5 N-pentane, isopentane, and you can see it is a neopentane. So if you talk about the boiling point scenario, as branching is more here, it will be less. One branch less, no branch more boiling point. You understand? Clear? It's very, very important. The greater the branching, the lower is the boiling point. Very important point, na? Very important point. Very important point. And और एक important point है melting point. Melting point. So melting point is related to packing efficiency in the solid of the alkane. So variation of melting point, you see, the general increase in the molecular mass, the trend is not as regular as the boiling point goes. Why? Because carbon atom, number of carbons, इसका boiling point कम है. As carbon number increases, the melting point increases. No doubt about that. No doubt about that. But you can see there is an increase, there is a decrease, there is an increase, there is a decrease, there is an increase, decrease. It comes like this. If you can see a carbon 2 का, you can see carbon 4 का, you can see carbon 6 का, है ना? Wherever you see even number carbons has high melting point, odd number carbon. Next odd number carbon. हर odd number का नहीं है. Are you getting? So that seesaw shaped graph is getting. Clear? Very important. Very important. You understand? thumbs up चाहिए और सादा पानी चाहिए thumbs up देना यार. Okay, right. Talking about now, solubility, alkanes are non-polar, so that immiscible with water. Everybody knows they are nothing but petrochemicals and oils, and they are also soluble in most organic solvent. For your kind information, alkanes themselves are solvents. Okay, talking about density. Density. Alkanes has low density. Low density. So, density of alkanes is directly proportional to molecular weight. So, density is equal to weight by volume. Alkanes actually exist as zigzag. It goes like a zigzag. So, what happened? As carbon number increases, its molecular weight also increases, right? And also molecular size also increases. Therefore, which compensate. So, density increase is not that great. So, maximum density for alkanes less than 1 gram per milliliter. That is the reason why you put any alkane, it float on the water. Alkane float on the water. Q, it exists in chair form or it exists in boat form. Okay, hi. Is this Abhinav? Is this Abhinav? Who is that unknown? Who is that unknown? Abhinav? Okay. So, chemical properties of alkanes. So, alkanes are, sorry, I forget always your name, Abhinav, Anirudh, sorry, Anirudh, love you better. Okay. Okay. Talking about alkanes are fairly unreactive because carbon bond is completely saturated. Therefore, they are paraffins. Para means less, affin means reactivity. Alkanes are less reactive. Thank you, beta. Alkanes are less reactive. So, I feel very happy whenever I study chemical properties of alkane and P block group 18. Group 18 elements are less reactive, no chemical reactions. Happy. Alkanes, they are paraffins, less reactive, so और ज़्यादा chemical reactions नहीं होगा. So here also double happy. Understand? Okay, talking about fairly unreactive. They undergo combustion reactions, थोड़ा मोटा oxidation reactions and halogenation reactions. सिर्फ 3 reactions हैं. So they can undergo combustion. Combustion means burning, complete burning. हाँ ठीक है बेटा, complete burning होगा and incomplete burning होगा. When they undergo reaction with oxygen in air completely, carbon dioxide and water, भी energy देना है. हाँ ये फायदा उठा रहे हैं. So as these combustion reactions are extremely exothermic, alkanes are used as a fuel. Then only you can use the alkane as a petrol in your car, right? And incomplete combustion you can have carbon monoxide also. So, but the greater the number of carbon atoms, more energy is produced. Okay. So, handy tip, when you balance ना stoichiometry में आपको सीखेगा, so kitna number oxygen chahiye, so that you just take care of your balancing and all, and take this point as a notes, and it is a handy tip for you, right beta. Coming to halogenation, incomplete combustion oxidation भी देखेंगे यहाँ पर. Catalytic oxidation, this is very very important, it is there in the NEET, NCERT also. Ethane, when it is undergo oxidation, this slide is not that clearly visible, it is going to give you ethane in the presence of copper as a catalyst, so it is going to get ethanol. Is it visible? Is it visible? And you just say MO2 O3, you better you write like this, MO2 O3, MO stands for molybdenum, oxygen stands for oxygen only, it is going to get ethanol, catalyst changes the product. And manganese acetate, it is going to give acetic acid, ethanoic acid, ख्याल में रखो. Got it beta? Got it? Yeah. Next, chlorination of methane. So chemical properties of alkanes. So alkanes undergo free radical mechanism, I just want to say, halogenation of alkane. Halogenation of alkane. In this halogenation of alkane, you take CH4 in the presence of chlorine, in the presence of light. Okay, so CH3Cl plus HCl is formed. What are the things you need to understand? Subedi, hi. Alkane से एक hydrogen removed, so I just want to write one hydrogen atom from alkane is replaced by one halogen. This is the simplest step. So if it is halogen, reactivity fluorine is greater than, chlorine is greater than, bromine is greater than iodine. You will be understanding the various reactions of the halogenations in haloalkanes in the grade 12 topics. And reactivity, yes Ishita, okay, yes, reactivity of hydrogens, benzyl hydrogen is more reactive than allyl hydrogen, is more reactive than tertiary hydrogen, secondary hydrogen, primary hydrogen, then methyl hydrogen. That's why we just give different types of reactions like this, my dear students. If you consider this is your alkane, क्लोरीन इन द प्रेजेंस ऑफ लाइट, जहाँ पर लाइट इस्तेमाल करना H न्यू लिखना है. ओके, सो दैट एक हाइड्रोजन इसमें मोनोक्लोरो डेरिवेटिव्स. सो यू विल बी आस्क्ड फाइंड मोनोक्लोरो derivatives, find monochloro derivatives in the NEET examination, right beta? So simply remove one hydrogen and replace one chlorine and find what is happening. Okay, सो यहाँ पर निकालना यार, सो CH3 and CH2Cl, you can remove here, you can remove here, दोनों बराबर है. When you talk about this one, when you treat with chlorine and in the presence of HNO, I can remove from one and I will get a question, a product CH3, CH2 and CH2Cl, and I can remove from here the same product. Then I can remove from here, so that I will get CH3 and CH and CH3 and Cl. So there are two monochloro products like this. So उसमें कौन सा मेजर होगा? प्रणव बालाजी, who is going to the major? Saranya, who is going to the major, here or that? जल्दी जल्दी, clear, जल्दी बोलो, waiting for your answer. Second, that's good, this is the major, क्योंकि this product is formed by replacing the secondary hydrogen. So this is your primary hydrogen, this is your secondary hydrogen, फिर भी this is primary hydrogen. So reactivity of the hydrogens, secondary hydrogen is more reactive than primary hydrogen. समझ में आ रही क्या? Clear? Understand? Yes. Now you can see what is the IUPAC name of the molecule? 2-methyl butane. Let us treat with chlorine in the presence of light, monochlorination, so that कितना products form होगा? देखता हूँ कितना होगा. Here I can make a chlorine here, I can make a chlorine here, I can make a chlorine here, I can make a chlorine. Use different pen or pencil, then only you will understand how many structural isomers that can be formed. You tell me, how many structural isomers that can be formed? Four. Now I can see this is a chiral carbon, yes or no? Yes or no? This is a chiral carbon, yes or no? Right? Any doubt? And this is a chiral carbon, yes or no? Like that I can see 4 fractions and 1, 2, 3, 4, 5, 6, 7 different products, but 4 structural. Like that different questions will be asked based on this. So when a structure is given, carefully use how many structures that can be formed, including stereo, excluding stereo. ये नीट एग्जामिनेशन में स्पेसिफिक किया जाएगा. Okay, Pranav? Yes. Now let's see chlorination of methane. In this chlorination of methane, we are coming to the end. So chlorine and methane are the reagents we discussed. UV or sunlight or heat is alternative energy source. Strong heating is required. So equations, chlorine stepwise reactions is a chain reaction. In this chain reaction, the reaction cannot be stopped. Of course, they cannot be stopped. Chiral carbon, Viresh, you just see the video recordings. Chiral carbon means carbon that generates optical activity. Carbon with 4 different groups is called chiral carbon. Is that fine, beta? Any question related to current topic or academics will be addressed in the class itself beta, right? Now methane chlorine gives rise methyl chloride फिर भी क्लोरिनेट करके डाइक्लोरोमीथेन क्लोरिनेट करके ट्राइक्लोरोमीथेन, आपका क्लोरोफॉर्म, दिस इज क्लोरोफॉर्म, किडनैप करने के लिए इस्तेमाल कर सकते हैं ना हंसने की बात नहीं है। क्लोरोफॉर्म रिएक्ट क्लोरिनेशन गिव्स राइज टेट्राक्लोरोमीथेन, सभी ये जो मिक्सचर में फॉर्म आता है ना, यू कैन सेपरेट इट and they are all used as solvent. Okay, that's good. Okay, free radicals are very reactive. We are getting a free radical mechanism here. Okay, so let's see the mechanism. This mechanism is of free radical substitution mechanism. So chlorine and chlorine, you just see initiation, जब initiate आता है ना, क्लोरीन बीच में एक बॉन्ड है, सो ए बॉन्ड पेयर ऑफ इलेक्ट्रॉन है। नाउ दिस बॉन्ड पेयर ऑफ इलेक्ट्रॉन होमोलाइसिस का वजह से ये बॉन्ड फ्री रेडिकल जनरेट किया गया, सो दिस इज अ फ्री रेडिकल, this is a free radical. Two chlorine free radicals are generated in the presence of light, So that is the initial step of the chain mechanism, is called initiation step. Hope you understand. Now ये initiate करने के बाद ये आगे बढ़ना, that is a propagation. Propagation में free radical methane पकड़ के methyl free radical generate किया HCl. So hydrogen पकड़ के HCl बन गया. So methyl free radical is generated. This methyl free radical is going to again react with chlorine to give rise methyl chloride, and chlorine free radical फिर भी generate हो गया. So it goes on like that. So कभी ना कभी ये reaction stop होना चाहिए. So here radicals created, it is endothermic. Now high energetic free radicals are going to die in the termination. So high energetic free radical, when they die, they become exothermic process. नीट एग्जामिनेशन में लॉजिकली क्वेश्चंस पूछा जाएगा. क्लियर बेटा? सो जो भी एक्सेस है, क्लोरीन फ्री रेडिकल मिलके क्लोरीन गैस जनरेट करना है, मिथाइल फ्री रेडिकल क्लोरीन फ्री रेडिकल मिलके मिथाइल क्लोराइड जनरेट है ना, एंड मिथाइल जोड़ी करके ईथेन इज फॉर्म्ड. माय डियर स्टूडेंट्स, सो this is very important. So during chlorination of methane, a small amount of ethane is also formed. ये unwanted gas है. Nobody think about that. Stability fine, clear, fine, right. So summary of the chlorination of methane. So initiation, propagation, termination, radicals created, radicals used, radicals regenerated, radicals removed. In this is endothermic process, this is exothermic process. ख्याल में रखो बेटा. हाँ. So due to lack of reactivity, alkanes need a very reactive species. Free radicals are extremely reactive species, and to persuade them to react, free radicals need to be formed by homolytic fission of covalent bonds. This is done by shining by UV light, or you can take it for in the high temperature on the vapor phase. Chlorine radicals are produced because of the chlorine bond is the weakest. I already shown the homolysis, and you only need one chlorine radical to start the entire kick-off reaction. With the excess of chlorine, you will get a further substitution products and mixture of chlorinated products are generated. So, my dear students, so we completed most of the reactions, and the cracking and all we don't need it because it is outside the game, catalytic cracking and all. And today we discussed a great concept, Newman projections and conformation isomerism, and also connected to the yesterday's preparation of alkanes, we discussed the physical properties, boiling point, melting point, okay, and the densities and the chemical properties, oxidation, catalytic oxidation, NEET में जो important point है वो भी बता चुका, and also we discussed about chlorination of methane and halogenation, monohalogenated products for the different compounds. So you please like this session, so and share this session, subscribe for the NEET channel. Also in the description box we have given Infinity Learn this Telegram channel. You please join, you will get the notes of the entire lesson, and also you will be getting updates regarding that. Okay, thank you very much. फिर मिलेंगे. Alkenes is tomorrow's topic, and you please do work on this topic. Okay, thank you. God bless you. Bye bye.